Hello, today I will be talking about how to configure and use the PWM with timers. Most of the code that I will be using in this video are the codes that I used in the video where I talked about timers. So in this video I will only need to make some modifications. Here is the basic code from the previous video. I removed the code related to port C because in this video we are going only to use the port B. In the port B we need to enable the peripheral clock and we need to set the mode and the configuration for that port. Here I am resetting the bits related to this configuration, and here I'm setting the mode. The mode was the first change that I did. If we go back to the reference menu, you see that the mode that we were using was maximum speed 10 MHz. But PWM needs more than this, so we are going to use maximum speed of 50 MHz. And the mode is general purpose output push-pull, which is 00, but since we resetted the values, 00 is already there. Back in the code, we have the alternate function that we are configuring to use the port B pin number 3 to be used as the timer 2 channel 2, and in here we are enabling the timer peripheral clock. The next line we are setting the prescaler value. In the next line, in the ARR register, is where we set the value that we want to count. So in this example, I will be counting until 99. Now we need to set the duty cycle. The duty cycle, if we go to the reference menu, we can go to the CCR register, and here we have 4 of these registers. Since we are using the channel 2, we need to use the CCR2 register. So this is the register that we are going to set a value, and this value will be the duty cycle. So in the code, let's access that register and set a duty cycle. Let's say that I want a duty cycle of 50%. So I set the value 50. Keep in mind that the value of the duty cycle is related to the value that we are passing to the ARR register. In this case I have 100, then 50 would be 50%. If I had 1000, 50 would be 5%. So we'll need to check this. The next thing that we need to set is the preload register, because when we change the duty cycle, if we are not using the preload register, this value is immediately changed. So depending on the application, this can be a bad idea. It's a good thing to use this preload register to only make the changes after an event. So if we go to the reference menu, we can see that we have a bit related to this preload. So let's go to the description. The preload value is loaded in the active register, which is the register that we set the duty cycle at each update event. Then let's enable this preload. Now we need to enable the output channel for the PWM. We can go to the reference menu and we can see in the CCER. So we have here the CC2E. So we need to enable this bit 4. So let's enable, and in the next line we start the counter. Now we can save, compile, and flash the microcontroller, and as you can see the LED is blinking with a duty cycle of 50%. If we see this in the logic analyzer, we see that for a timer of 100 and a duty cycle of 50%, we have 100 milliseconds and a duty cycle of 50 milliseconds. Now let's change from 50% to 10%, and as you can see the LED now is dimmer. And if we go to the logic analyzer again, we can see that in 100 milliseconds we are 90 milliseconds off and 10 milliseconds on. That's what we want.